I'd like to quickly go through now is adding OCL constraints. So this is the model that we've been working on, and what we have so far is we have flavors and ice cream defined, and we have an association defined between flavor and ice cream going both ways. So in essence, if you were on a given flavor, you would know what ice creams the flavor had been used in, and this is this used in association here. And a given ice cream knows the flavors that it uses, and that is flavors. And the association itself is also named flavors. What we see is that an ice cream consists of one or more flavors, and a flavor, the number of ice creams we use on here, we just give a star because it's essentially 0 or more. We could have a flavor that isn't in any ice cream, or we could have a flavor that's used, say, in every type of ice cream we have. Well, so what we want to do is we want to add some OCL constraints to this simple model. And what we do to do that is we come over here into our nodes, and you see we have one called constraint. What we do is we just drag that over onto the canvas. And when we do that, we get this very, I guess, basic predefined constraint with a name, constraint 1, a visibility, and a context which is currently undefined. And then the specification is just this empty string. All right, so for the first constraint we'll add one that is similar, at least a bit, to what's in one of the exercises. We'll say, well, we want the name of a flavor to be non-empty. So it doesn't make sense for the name to be an empty string. It should be called something. So what we can do is we can just give it a name that makes sense here for the constraint. So we'll just call it flavor not empty. And we will go ahead and save that, and you see that appears in the box. Now the context should be, when we write the OCL constraint, if you think about, well, I want to use self, and then self is really an instance, an object of the class that we're defining, that should tell us then what we want to have as the context for where the constraint will sit. And so in this case, since we are talking about instances of the flavor class, then the context will be flavor. So we can come in and select that. And again, we see this is here now, and the context that we have is flavor. All right, we can then right-click, and we see Edit Constraint, and it says Using Essential OCL Constraint Editor. It's a bit of a weird title there. And what we get is we get this little editor box that we can use to actually type in our OCL constraint. And I believe this uses xtext in some ways. There isn't a separate xtext OCL console as well, so I'm not sure if it just integrated that in. I'm pretty sure it does. But what we get once we have the context set up is we get something that looks like a normal Eclipse editor with some syntax highlighting and also context completion. So if we type self and hit dot, what we can do is we can ask it to complete the context. That's a control space. On a Mac, I believe it is also a control space on Windows. So if we hit that, and then we see the properties we have. So we have name, and we have used in, and then we have all these various other things, which is basically just everything in OCL. So we can select name, and then we can hit a dot again, and hit this, and unfortunately we don't get what we're looking for here. This is still, I think, a bit buggy, but really what we're looking for is operations on strings, and if you start typing the operation you want and then hit space, it appears. This is size, and so maybe, I'm not sure if we went to string here, if we drilled down, if it would do anything for us. No, it doesn't look like it. All right, so I guess the advice is just to start typing it, and you'll see it there, size. And the invocation of it looks a lot like a method invocation. And so we can say, well, the size is greater than 0. Now, if we save that, click someplace outside, then what we have is down here we see that the specification is given, and we can also see that if we drill down into our model, we'll see that it sits under flavor. The annoying thing is it doesn't actually show up in the box yet. And one thing you can do to make it show up is save, close, Sometimes you have to right click and say open. And now you see that this is actually in here. Okay, so that's one constraint. So say we want to add another constraint, and what we want to do is we want to say that a given flavor is only used in a certain number of ice creams. Of course, we could potentially modify this with the multiplicity, although it gives us only these selections, so the actual multiplicities that we normally have available to us actually aren't available here. I'm not sure why that was a bit odd that it actually changed that. Let me put that back to what it was. As I said, this is definitely still sometimes alpha software. You know, we would like to maybe be able to type something like 0.4, 0.5, but we don't really have that option here. We may be able to just come in here and type it, and that seems to work. Right, but what we also may want to do is we may want to add this instead. So we'll just leave that as star. We'll add this as a constraint. Another way that we can do the context is we can come in here and we can just do this arrow, and that gives us a context then, and it goes ahead and sets the context to flavor. And I think it's nice on the diagram because then we get this link so we can really quite easily tell which of the classes it goes with. And now we can actually give this a name again. So say flavor not overused. And then again, we need to edit the constraint itself. So edit constraint, come here, and what we want is, again, this is self. And again, self is a stand-in for any instance of flavor. So we're saying for any given flavor, if we look at used in, and because used in is a set instead of being a string, we need to use this arrow notation. Then we can select size. And maybe we say that, well, it can't be used in more than 10 different types of ice cream. So we could write that. We could also say something more complicated and say it needs to be used in at least 2. And if we wanted to do that, we would just come back here and enter it like that. But for now, we'll just stick with what we originally had. And this tells us then that this flavor is used in at most 10 different types of ice cream. Okay, and then again, we have this problem here. So if we save our diagram, close it, right click on it again, and open it, we'll see the expression that we just defined in here, and it's actually tagged as being OCL. Because of the constraints we write, we could just have textual constraints. We don't need to use OCL. We could just actually type in something saying this flavor cannot be used in more than 10 different types of ice cream. And that would be a constraint, but it wouldn't be one that we could automatically enforce. Okay, so that's just a basic introduction to typing in these OCL constraints, and I guess how you do it using Papyrus, and what you should expect to see as you're doing it. If you have any questions about this, please feel free to post them in the discussion groups or send me an email. Thanks.